probability by using Poisson table. As you know or you have learned before how to use binomial table. So it is same as a binomial table and you can apply for Poisson table. Okay, so for example, if x with Poisson distribution where the lambda is 5.5, so you open the book, the statistical table part Poisson on page the Poisson table is start from page 10. So for lambda 5.5 is at page 13. So to find x greater than and equals to 5, so we just look at the table. Directly you take from r equals to 5 and lambda 5.5. So the answer is 0.6425. Okay, this is directly from the table. So we read all the x in the table is greater than and equals to. So for x less than and equals to 5 means that 5 is also included. Okay, it's 5. So 5 is also included. So because of in the table, we read the greater and equals to. So we cannot take f, the less than part. So we have to take all, which is 1, minus with the part that does not include, which is x greater than and equals to 6. So read from the table. So we got 0.4711. So the answer is 0.5289. Okay, and then when we want to use table to calculate px equals to 5, so means that we have to take px greater than equals to 5 minus px greater than equals to 6. So x greater than equals to 5 is at part A. We already read from the table. Okay, minus with x greater than equals to 6, which is here, 0.4711. So when you minus, you will get 0.1714. And the last one for D, 3 to 8, where 8 is not included. We got 3 and then 8. 3 to 8. So we have to calculate from 3, 4, 5, 6, 7. So to read from the table, so we have to take at x greater than equals to 3 minus with x greater than and equals to 8. Because of 8 is not included, so we minus at 8. If you take 7 greater than equals to 7, so you minus 7. So that's why we have to take at 8, because of 8 is not included. If 8 is included, so we have to take the next number, which is 9. So by reading from the table, so you got 0.9116 minus with 0.1905. So calculate by using your calculator. So you got 0.7211. Okay, so next example. So we got an average of 3 cars arrive at highway toll gate every minute. So if this street is approximately Poisson distribution, what is the probability that exactly 5 cars will arrive in 1 minute? Okay, so we know that the average is lambda, so we got 3 cars arrive every minute. Means that for every minute we got 3 cars arrive. So by define, x is the number of car arrive in 1 minute. So our distribution for part A, so because of the question asks you in 1 minute, so we got x distribute with Poisson distribution where the lambda is 3. So we have to find 5 cars. So x equals to 5. Okay, so for all x equal, there's an equal. So we can just directly use the formula e power of negative lambda, where lambda is 3, and then 3 power of 5 over 5 factorial. So when calculate in your calculator, so you got 0.1008. And then B, 7 cars will arrive in 5 minutes. Okay, so we know that in 1 minute, your lambda is 3 for 1 minute. But the question here stated in 5 minutes. So we need to find the new lambda in 5 minutes. So you need to multiply 3 with 5. So we got 50. So this is the new lambda. So we got the new distribution of Poisson. So we got new lambda, which is 15. So we need to find 7 cars. So Bx equals to 7 by using formula as well. So e power of negative 15 times 15 power of 7 over 7 factorial. Then you can calculate in your calculator. You will get 0.0104. And next example. In a library, the mean number of students borrowing books between 8 p.m. to 8:40 p.m. is 8. To find the probability that no student borrows books in the first 5 minutes. So we need to calculate, because of from 8 to 8:40 minutes, we got 40 minutes. So the lambda for 40 minutes is 8. But the question for A, the question asks you to find for the first 5 minutes. So we need to find the new lambda. So we know that for 8 to 8:40 p.m., the lambda is 8. We know that it is 40 minutes. But we need to find for the first 5 minutes. So we need to calculate for 1 minute first. So we know that 40 minutes, the lambda is 8. So for 1 minute, we need to divide 8 with 40. So we got 1 over 5 or 0.2. And for 5 minutes, we need to multiply with 5. So if we take 1 over 5 multiply with 5, so we got 1. So 1 over 5 multiply with 5, got 1. So the lambda here is 1. Answer the questions. So we have to write the distribution, which is the Poisson. In the first 5 minutes, we got lambda equals to 1. And then the question asks to find no student, because x is a number of student. that borrows books. Okay, so px equals to 0. So we have to use formula to make it easy. Over 0 factorial. So when you calculate in your calculator, so you got 0.3679. Okay, then B, at least one student borrows book in the first 15 minutes. At least one, which is x greater than n equals to 1 for the first 15 minutes. So we already know for 1 minute the lambda is 1 over 5, so we just multiply for 15 minutes. So the lambda, take 1 over 5 in 1 minute, multiply with 15. So we will get 3. So this is the new lambda for part B. We need to write the new distribution where x is a Poisson distribution with a new lambda 3. So we need to find at least one student. So px greater than equals to 1 equals to, by using Poisson table, so you will get 0.9502. Okay, and then C, we need to find the probability that 4 to 6 students borrow books between 8 p.m. and 8:40 p.m. So we know that the lambda from 8 p.m. to 8:40 p.m. is 8. So write a new distribution with a new lambda. So we need to find px from 4 to 6. There's an equal sign because of the words 2. And then 4 to 6. 4 to 6 both included. So we need to take at 4. Px greater than and equals to 4 minus with px greater than and equals to 7. So when we read from the table, so we got 0.9576 minus 0.6866. So when you minus, you will get 0.271. Now we are going to learn how to find mean and variance for a Poisson distribution. So if x is a Poisson variable with parameter lambda, then mean is equals to lambda, and variance also equals to lambda, and standard deviation is equals to set of lambda. So if x, we are going to do this example. If x is a Poisson distribution where lambda is 1.8, so find the mean, variance, and standard deviation. So as we know, the mean is equals to lambda, which is equals to 1.8, and the variance equals to lambda, which is equals to 1.8, and the standard deviation, there is no square, so we just take a square root of 1.8. So by using your calculator, you will get 1.3416. Take until 4 decimal places. So now you know how to find the Poisson distribution, and also you should know how to find the mean and variance for a Poisson distribution. So you can do this exercise by yourself and check the answer. If you got any problem, you can just ask your lecturer.